In this session, we are going to start the next chapter, chapter number 3, current electricity. So the current means the rate of flow of charge. So current is denoted as a symbol I. I is equal to Q by T. Q is equal to Ne by time T. So N is a number of electrons, E is a charge of the electrons. So these things we are studied in the previous unit itself. So what is current? If you want to define the current is defined as amount of charge flowing per unit area in unit time. So that is called as a current definition. The SI unit of current is ampere and the symbol is capital A. So the current is a scalar quantity. It is not a vector quantity. It is a scalar quantity because it will obey the additive nature, algebraic sum natures. So the current I3, which is the value of the 7 ampere, is flows towards the junction at this point here. So it will divide into two currents. So it will be a I1 is a 2 ampere and I2 is a 5 ampere. So it will obey the additive nature. It does not depend upon the direction of the current. So the current is a scalar quantity. It depends only the magnitude value, not a direction. Next, we have to come to that. So how the current flows in a material? Very simple. In order to understand this concept, we should know the atomic structure. So the atom consists of proton and neutron, which is called as the nucleus of the atom. The electrons are revolving around the atoms. As the formula 2n squared, if you substitute n is equal to 1, so the number of electrons in first orbit is 2 and the number of electrons in second orbit is 8 and it is so on. So in any electron, the outermost orbit is called as a valence orbit. And the electron present in the outermost orbit, that is the valence orbit, is called valence electron. When the external energy is supplied to the any material, so that will be supplied to the atoms too. So what will happen? The outermost electron in an atom which absorbs, which gains extra energy and it will be ejected out from the atom. It is not ejected out from the material, it will be ejected out from the atom. Thus we can define that this process is called ionization. The process of removing an electron from an atom is called ionization. The same thing happens here. So when the external energy is supplied, the valence electron will ejected out and it will become a free electron. So that electron is called as a conduction electron. Now we can picturize that what will happen inside the metal or a conductor. So the metal or a conductor contains a more number of atoms as we shown in the above picture. So the valence electron will become a free electron and that particular atom will become a positive ion because it loses the electron. So it has a lot of positive ions and free electrons are randomly moving here and there because there is no force of electrostatic force of attraction between the nucleus and the free electron. So the free electrons are moving here and there. It is not bounded inside the atom. It will come out from the atom and it is freely moving here and there. If you supply the battery, if you connect the battery across the conductor, that means if you supply the potential difference to this material or the metal, so what will happen? This randomly moving, the random motion of the free electrons are drifted towards one particular direction. Which direction? Yes, it is very evidently we are seeing that the electron is a negative charge and this is a positive terminal of the battery. So this positive terminal of the battery provides the attractive force towards a negative free electron. So all the negative free electrons are drifted. It will be changes its direction. That is called as a drifting. So drifting means changes. So all the electrons are drifted towards a positive terminal of the battery. So that is the electron flow direction is here. But conventionally, we are taken that the current direction is always opposite to the electron direction. So the current direction is from positive to negative and the electron direction is negative to positive. So the conventional direction is always opposite to the direction of flow of electrons. So when the potential difference is applied, the randomly moving free electrons are drifted and move towards the positive terminal of the battery and this velocity is called as a drift velocity. So we will represent the drift velocity as v suffix d. So it is a velocity v, small letter v, and the suffix we have to put d. So the drift velocity can be defined as a mean free path by time. So very simple. Velocity means distance by time. So here what is the distance? The distance traveled by the free electron between the two successive collision is called mean free path. Again I will say that what is the lambda? Lambda is the mean free path of the free electron. The distance, average distance traveled by the free electron between two successive collision. And collision time means the average time taken by the free electron between the two successive collision is called collision time. So the distance by time is a drift velocity. And also we can define that mobility of free electron. So it is defined as the drift velocity of the free electron per unit electric field. That means per unit potential difference. So very simple. We are seeing that what is the mechanism of what will happen when the current means the rate of flow of charge. So how the charges will obtain means that is a free electrons from the atom. These free electrons are randomly moving here and there without the supply of the battery. That means no potential difference is applied, means the electron motion is a random motion. When the potential difference is given, the electrons are drifted towards the positive terminal of the battery. That drifting velocity is called as a drift velocity, and the mobility of the free electron is mu. The students may have some doubt. Sir, what is the difference between electromotive force and potential difference? So the electromotive force is a work done by the source. So work done by the source means here this battery is a EMF. So what is that? Work done by the source. This battery is a source here. Work done by the source in taking a unit charge once around complete the circuit. So what is that? So when the potential difference is applied, this cell do some work to move the charge from here to here, from starting from here and ended up to here. So that work done is equal to EMF of the cell. So it even exists in the circuit is not closed. That means it will exist in the open circuit. That's why we can say that for a battery with 1.5 volt, we can buy it from the shop. So that is the EMF is equal to 1.5 volt. Okay, when we connected this battery to any circuit, so this circuit has a, what is the potential difference? The work done to move a charge from one point to another point. From here to here, what is the potential difference? We can measure that. So if there is any resistors are given, we can connect the voltmeter across the any resistor. We can calculate the potential difference. But EMF is a maximum potential difference available in the circuit is called EMF. So very clear. So EMF is a open circuit, potential difference is a closed circuit. This is a work done by the source for the entire circuit. For the potential difference is work done by the source between any 2 points. So the EMF is a cause and potential difference is a effect. So listen students, it is very clear, easy to understand. I will show the pages very slowly in order to copy in your classwork note. So first we see that what is current, the rate of flow of charge, and the SI unit of current is ampere. Then we find that current is a scalar quantity, and next we will going to understand what happens when the potential difference, when the battery is connected to the cell, or sorry, it is a material. Yes, it is a second page. Then the third page, and this is a fourth page. Thank you students.